Hello, and in this video we're going to look at composite functions again, but we're going to look at how we're going to use equations to find composite functions and a little bit about the domain of composite functions. So we're going to start off with some equations. We have two functions here, f and g, and we're going to evaluate them similarly as we did in the previous video. So in this case, looking at a, we're going to plug in, we want to know what g of 4 is. So we're going to take our function g of x and we're going to evaluate it for 4. So we're going to find g of 4 first by plugging in the 4 into our g equation to get the answer for g of 4. So we put 4 in right here. We get 16 times 2, which is 32, minus 1, which is 31. Once we've evaluated that portion of it, then we want to find f of 31, because now we know this is 31. So then we put 31 into the f function, and it would be 3 times 31 plus 2. So we're going to get 93, so 95 here for this problem. So for part A, where we are evaluating f of g of 4, we first of all find g of 4. We then take that answer and we plug it into f. So we're going to do the same thing here on the second one, but it looks like we're going in reverse. So we're going to find f of 2 first. F of 2 is going to be 3 times 2 plus 2. So that's 8. Then we're going to take that answer, and that becomes this value, so we're going to take g of 8, which is 2 times 8 squared minus 1. So that's 64. It's 128 minus 1, 127 for the answer to this one. Now in the last two examples, we're going to evaluate the same function twice. So we're going to do f of 1 first. So we're only needing this function here in this example. So we're going to 3 times 1 plus 2. That's going to give us 5. And then we're going to evaluate function for 5 now, because we just did this part of the function and got 5. Now we're going to evaluate f again with 5. So that's 3 times 5 plus 2. So that's 17 for this one. Now on g of 0, we're going to evaluate g twice. So we're going to do g of 0 first. In that case, we're going to have 2 times 0 squared minus 1. So that's going to be negative 1. So we're going to have g of negative 1. That's going to be 2 times negative 1 squared minus 1. So that's going to be positive 1, 2. So this answer is 1. Alright, now continuing on with our next function. Next example, we have some square roots here. So we're going to take g of 4 first. So we're going to evaluate. This is going to be 3 times 4 to get the answer, because that's 3x. So that's going to be 12. And then we're going to evaluate f of 12. So we plug that number into this function and we get the square root of 12 plus 1, which is the square root of 13. That's our answer for this first example. Now our second example, we're doing f of 2 this time, so we're going to take f of 2. So we put 2 in there, and it's going to be the square root of 2 plus 1, which is the square root of 3, and then we're going to evaluate that for g. So that says multiply g of the square root of 3, which is going to be 3 square root of 3. Because that's going to be plugging that in there, multiplying by 3. Now f of 1, we plug in 1 into f of x. So we're going to do square root of 1 plus 1, or the square root of 2 on that one. And we're going to plug it into f again. So we're going to get the square root of the square root of 2 plus 1. Would be our solution there. Now g of 0, we're going to have 3 times 0 for the first one, which is 0. So g of 0 is 0, and then we're going to do g of 0 again, which is still 0 here. All right. So that's how we evaluate. We do it the same way as we do the graphs, except we're not looking for the points in there. We're plugging in the values into the equations in order to find our numerical values. Now, the second and last part of this is the domain of composite functions. So if I'm looking at f of g of x here, and we're looking for the domain of this function g of x has to be defined here. So we have to look at what defines this, what's our domain of this function. So our domain here is all real numbers except 0. So that's going to be part of our domain of a composite function. Then we have to look at what happens when we evaluate f. Well, f also has a restriction here. So we can't let the domain of f of x is all values not equal to, so the domain of f of x is all values except -1. So x cannot equal -1 on this. So what we're saying here when we say that is true, but we're plugging it in here, so that means g of x cannot equal -1. That would be also, or I'm sorry, +1. It's 1 minus 1 is 0. So what we would want to do here is set g of x 2 over x. So it's not equal to 1. We're going to solve this and figure out if there's an additional part of the domain. This is going to be part of our answer, but we also have to figure out when this is going to be a problem in there. So we're looking at when is this -1, when is that function also -1, because if it is, it's not going to be evaluated well. And 2 divided by 2 is 1, so x here is not equal to 2. So that means we have 2 restrictions on our domain. So we're going to add to this restriction as well. So our total answer here would be all real numbers except 0 and 2. Both of those would not be in our domain. We cannot have 0 or an undefined place here, and we can't have g of x being undefined in here, so it can't be 1. G of x could not equal 1. If it did, it would be undefined in here because it would be 1 minus 1 equals 0. Okay, now let's look at our final example of finding the domain of a composite function. So we're going to do the same thing here. We're going to look at f of g of x. Okay, so we're going to look and see when g of x is restricted. So in this case, this is a line, so the domain of g of x is all real numbers. So we don't have any restriction there. So then what we have to worry about is when is f of x restricted. So f of x has to be greater than, it's a square root, so f of x is restricted in that x minus 2 has to be greater than 0 or equal to. It could be equal to also, greater than or equal to 0. If it's not, then we have a negative number and it's going to be a complex value, or not a real number. So we're going to solve this so we have x is greater than or equal to 2. Now that's what our value g has to be. It has to be bigger than that. So what we would do is take our g of x, because g of x is what's inside, and we know that the inside function has to be greater than or equal to 2. We would take the g of x function, g of x has to be greater than or equal to 2. Because g of x is on the inside, and we're saying that that x value has to be greater than or equal to 2. That means the g of x value has to be greater than or equal to 2. So we just take 1 minus 2x greater than or equal to 2 and solve that. So move the 1 over by subtracting. So we have 1 is greater than or equal to -2x. we divide by -2. In dividing by -2, we have to exchange the symbols here. So we're going to x is less than or equal to, not greater than or equal to, -1/2. So this is our restriction. We can say the set of all x's such that x is less than or equal to -1/2 is our domain. So that means if I put that in there, that we should have those values should work in the function. But if we pick anything smaller than -1/2, if I put in like -1, -1 is smaller, I'd stick that -1 in here, I would get -1, and then I'd put -1 in here and get -3, and that would be impossible. We can't take the square root of -3. All right, so that's the problem there. So this is equations with composite functions and domain.